Thank you. So I guess this is one of the special lectures of SIO 209. The title of the course, as you all know by now, is Climate Change in 4 Dimensions, Scientific, Policy, International, and Social. You can see that it's missing a 5th dimension, which is the human side of the story. So that's what I'm going to touch on. What does it all mean to people living on the planet? In particular, I'm going to focus on the so-called bottom 3 billion. It derives from the so-called bottom of the pyramid, which is economist Prahalad from University of Michigan talked about. So let's get a brief introduction about who these 3 billion are. And I don't know how many of you know, the United Nations last year started a major ambitious program called Sustainable Energy for All. What really caught my attention with respect to this course is the statement by the Secretary General Ban Ki-moon, saving our planet, lifting people out of poverty, advancing economic growth. These are one and the same fight. I'm just going to give you a beautiful example of that, where that's true. So in terms of this so-called bottom 3 billion, it lists the world population in terms of 2. Those who are living on the extreme left, less than $1 a day. So let me focus somewhere between $2 to $2.50 a day. It's about 3 billion. Roughly 40% of the planet, okay, is living under $2 a day. So it's sort of convenient. At least my own research now is focused on thinking of the planet. There are 2 planets. One is 4 billion who have access and are addicted to fossil fuels. I'm certainly in that 4 billion. The second is the 3 billion who either cannot afford fossil fuels or have no access to fossil fuels. That's the 3 billion I'm going to focus on. What does climate change mean to them? In particularly focusing on this mitigation adaptation issue. So let's start. I'm going to give a background of what you already heard in this course about climate change. This was released by the Scripps Institution of Oceanography about a month ago, I think. Documents a so-called Keeling curve starting from 1960 up to now, a month ago. So carbon dioxide, which was about less than 270 parts per million before the industrial era, has hit about 400. Okay? So what does that mean? I'm sure you've learned by now, carbon dioxide, because of its long lifetime, covers the planet like a blanket. And just like a blanket keeps you warm by trapping your body heat, this carbon dioxide blanket traps the infrared heat coming from the planet and keeps the planet warmer than what it would have been otherwise. And this is where the story starts to be different. What you would have heard about global warming is primarily in terms of fossil fuel combustion and carbon dioxide. It turned out there are numerous other pollutants we are adding to the planet or dumping in the air, which is also adding heat to the planet. So the area of the pie is roughly proportional to the heat we have added through this thickening of the greenhouse blanket. So the number on the left for carbon dioxide is about 1.7 watts per square meter. Watt is the same energy as what we say 60-watt light bulb. Square meter is square meter of the Earth's surface. And you see the other gases. CH4 is methane. HC is halocarbons used as refrigerants. CFCs. N2O is nitrous oxide, comes from fertilizer use. Ozone, we don't dump ozone to the air. We dump other gases which produce ozone. This is not ozone in the stratosphere which is involved in ozone destruction. This is ozone part of smog which we inhale. And then the last one is particulates, not gases, but black carbon. It's basically soot. And we call it black carbon because it's one of the strongest absorbers of sunlight per pound of the substance in the air. So when you add up all these numbers, you see that these other pollutants are contributing as much, if not more, to the current warming. Okay, that's key to remember. So what does this pie mean? It turns out if we just focus on carbon dioxide, which comes from fossil fuels, and we continue business as usual, we will shoot past, the planet temperature will exceed 2 degrees by middle of this century, another 35, 40 years from now, and go past or exceed 4-degree warming by end of this century. So we have to, because of its long lifetime, we have to start reducing carbon dioxide starting from now. But the bad news is, even if you drastically cut carbon dioxide, say by 50%, okay, in another 35 years, and nearly 100%, I mean, eliminate all fossil fuel emission by end of the century, the planet would still warm up more than 3 degrees. The simple reason is we have delayed taking actions on carbon dioxide. So while reduction of carbon dioxide is critical and a must to prevent disasters, century or longer time scale, that itself is not going to be enough to avoid the impending changes in this century. And the only way to do that is to cut down these other pollutants. I'm going to name about 4 of them, short-lived climate pollutants. Methane, lifetime is 10 years. Halocarbons, particularly the HFCs we are targeting as refrigerants, it's about 10, 15 years. Ozone is few months, and black carbon is few weeks. So what does that mean? If we take actions to cut black carbon now, they're gone within few weeks from now. So these short-lived climate pollutants gives us an opportunity to cut down the warming in our lifetime. Okay? And I want, before I proceed, I'm sure we have talked about it here. What does exceeding 2 degrees, 3 degrees, 4 degrees mean? Here I'm showing the temperature over the last 50,000 years. And you see that the Earth goes through ice ages, glacial to interglacial. The problem with the warming now is we are currently in an interglacial period, if you look at the top one. And if we heat the planet by 2 to 3 degrees beyond that, then that planet is a different planet we have not experienced in a long time. Okay, even if you look at the last 1,000 years. And a lot of the focus on climate change is on extreme weather and etc. But we have to think of the climate as a climate system. So it's just not temperature alone. Once you start heating the planet, you change the glaciers, you change the ecosystem, you talk about migration of humans, species, birds, etc. Okay? So everything would change. And we don't have yet a model which will tell us what that change is going to be. So it's best to assume once you exceed 2 degrees, it's a different planet. Okay? So this is just to show how long we have known about this non-CO2 pollutants, warmers. We think of, in the public media at least, we think of climate change, what is CO2 comes to mind. We have known about these for at least 35, 40 years. This is just a background of some of the results I'm going to summarize before I move on, those of you who want to read up these papers. So this sort of summarizes what I just said. The red curve is business as usual. It is showing temperature from 1900s to forecasting it about 2100. So the red line is what I meant by saying if we continue business as usual, you're going to go past 2 degrees by mid-century and 4 degrees. And you can see that there's a huge uncertainty in any projections we make, minimum factor of 2. The key thing about uncertainty is it goes both ways. Okay, it can be twice as large as what we are saying or twice as small. And if you look at the blue curve, that is drastic reduction in CO2. And you see that CO2 reduction doesn't do much until later this century because of its long lifetime. And the black one is cutting down the short-lived climate pollutants. You see how you get an immediate relief. Okay? So when you put the two together, it's a light green, we still have at least a 50% probability of keeping the warming below 2 degrees. Okay, that's one way to take it, and I'm sure Professor Charlie Kennel would have talked about it. The science also clearly tells us we've got to adapt to at least 2 degrees Celsius. No matter what we do, we can't avoid that. Okay? So the science is pretty clear about how much we can mitigate, how much we can adapt. So I'm going to talk about what this 2 degrees, 4 degrees would mean to the 3 billion whom we have left behind. This is a new result, a sea level. And I had not realized this till I got involved in the sea level research. The red one is business as usual. So it's clear that by 2100, the sea level we would expect is anywhere between 7/10 of a meter to 2.5 meters. And reducing CO2 can do very little. But reducing CO2 is essential to avoid dangerous sea level rise beyond 2100. You can see the red curve is shooting high. The black curve is the short-lived climate pollutants. You can really see the short-lived climate pollutants can cut down sea level rise by as much as 30% and keep it under 1 meter. Again, a 50% probability. So I'm optimistic that we would mitigate carbon dioxide and short-lived climate pollutants. But what this recent research says is that even if we take the heroic efforts to cut CO2 and short-lived climate pollutants, we're still going to face about 2 degree warming and at least a meter rise in sea level. So this is a thing on what are the exposed assets to sea level rise. And just focusing on India, Bombay and Kolkata, they're exposing as much as close to $2.5 trillion. It's comparable to their national budget. And back home, New York and Florida, again, same. So there's huge implications. And the reason I'm raising that, I think it has probably brought up by Professor David Victor's lectures. The developing nations are sitting there saying, it's a problem you created, you solve it. And I talk to them, assuming they don't solve it, everyone is going to suffer. And so that's where the short-lived climate pollutants come in. We don't have to wait for other nations to take action. They can be unilateral actions, and this shows the cities exposed in terms of population. The previous one was resource, and you see that developing nations, including India, China, are on the top of the list in terms of the number of people exposed. So that's basically the background. Okay? Just to summarize, the greenhouse blanket has already become sufficiently thick. And if we continue business as usual, you're talking about at least a 2 to 4 degree warming this century. Okay? And we still have time to avoid such disastrous warming by cutting down CO2 and the short-lived climate pollutants and keep the temperature under 2 degrees. This shows the various species within the short-lived climate pollutants which contribute to that. Okay, methane is a major one. Hydrofluorocarbons. The thing about HFCs, it's a replacement compound for refrigerants. But we have other compounds which completely eliminates the effect of HFC. It's off the shelf. Okay, it's a question of policy we need. I'm going to take the black carbon issue, soot issue, and demonstrate how all of this links to people on the street. So the many sources of black carbon is the one coming out of diesel transportation, forest fires. You know, California is experiencing, as we speak, one of the major fires. It releases enormous amount of black carbon. smokestacks, that's brick kilns, and residential cooking. Okay, so I'm going to focus on the residential cooking. That's the 3 billion who have no access to fossil fuel. Sorry. And so they just burn whatever they can get their hands on. Believe it or not, a third of the man-made soot emissions come from residential cooking with solid fuels. Okay, so it's a major issue. Lest we think that the black carbon is the developing nation problem, this is brown clouds or backyard. It's taken by my colleague's wife, Sylvia Somerville. Richard Somerville was one of the lecturers here. Where are those brown clumps coming from? Just soot emissions from our diesel transportation. Here on this is transport from Los Angeles, Mexico, plus our own thing. So it's really a worldwide problem.